All right, this is section 2.1. It's the beginning of the chain rule, which is another huge rule along with the product and quotient rule for derivatives. The book will define it as a composite function, so the derivative of a composite function. And what you do is you take the derivative of the large function and then you take the derivative of what I call what's inside of it. In general, the general power rule says that you will bring your exponent out in front, rewrite it, lower the exponent by 1, and then take the derivative of what's inside. It will be easier for us to just go ahead and do some examples. So the first example I'm going to do is on page 137, number 2. When we go ahead and take this derivative, before we take the derivative, we want to rewrite this because we do not want to do a quotient rule. It's much easier to rewrite it and then take the derivative of it. If you notice, what we have is much more than an x. If I would have just had an x, so this is a side problem here, if this would have just been an x, my derivative would have just been negative 1/2 x to the negative 3/2. Because it's not just an x, this is actually using the chain rule. The derivative of this function, we're going to treat it just like it is a big X. We're going to pretend that the highlighted section is just a big X. We're going to bring out the 1/2. We're going to do what I say, rewrite the inside. We're going to lower it by 1, so negative 1/2 minus 1 is negative 3/2. And then the last thing we're going to do is take the derivative of what's inside. When I'm saying that, I'm taking the derivative of what's inside the parentheses. So the derivative of what's inside the parentheses, since it's not just an x like it was in the first side example I did here, I need to make sure that I am finishing this. In this case, it does just happen to be a 1. But in many cases that follow, that will not be the situation. So to finish this up, I'll just simplify it by writing negative 1 over 2, the square root of x plus 1 cubed. And I will stop at that point. I am jumping slides, and I'm going to jump to number 8 of page 137. In the next video, I will cover the trig functions. In this one, if I go ahead and just jump right into taking the derivative, we're going to pretend that this is a big X. And if it was a big X, we would just bring this out in front. So maybe I should write that off to the side. What if I had just a big X there? It would be 2, like this has out in front, x to the 5th. And I would bring this out in front and I'd write 10 x to the 4th. And that would simply be my derivative. I'm still going to do that whole step. 5 times 2 is 10. This time, though, I don't just have an x, so I have to rewrite what's on the inside and lower it by 1. There's my 10x to the 4th. But since this isn't just simply an x, I have to take the derivative of what's inside of the parentheses. What is the derivative of what's inside the parentheses? Well, the derivative of 6 is 0, and the derivative of negative x squared is negative 2x. I'm not going to leave my answer in this form, however you could. I'm going to go ahead and simplify it. I'm going to go ahead and multiply the 10 times the negative 2x, which gives me a negative 20x. And then I'll just go ahead and leave this as 6 minus x squared to the 4th power. I will continue on with some more examples on the second video.